Well, see this problem. A spring having a spring constant 1200 Newton per meter is mounted on a horizontal table as shown in figure. A mass of 3 kg is attached to the free end of the spring. The mass is then pulled sideways to a distance of 2 cm and released. Determine the frequency of the oscillations, maximum acceleration of the mass and the maximum speed of the mass. Our motive is, we have a spring and one end of the spring is attached at a constant end and one is attached with a mass. If you take this mass to some x distance and if you release that one, so the spring shows some oscillations. So from this phenomena we need to observe the frequency of this oscillation and the maximum acceleration attained by the mass and the maximum speed attained by the mass. That is our motive. Now come to the investigation part. The spring constant is given, that is K is equal to 1200 Newton per meter, and the mass which attached to the spring is given, that is M is equal to 3 kg, and is given that the mass is pulled sideways to a distance of 2 centimeters. So X is equal to 2 centimeters, that is equal to 2 into 10 to the power of minus 2 meters, and this can be taken as the amplitude of the oscillation also, because after pulling to that much end, if we release that mass, it will oscillate to and fro and makes the same amplitude. Assume that there is no friction between the mass and the table. Now come to the resolving part. We need to find out the frequency of the oscillation, that is nu. Nu is equal to 1 by 2 pi root k by m. This is the formula we know from the concepts. That is equal to 1 by 2 into 22 by 7 into root of k is 1200 divided by m is 3. So 3 ones, 3 400s, root 400 is 20. So finally I can write 20 into 7 divided by 2 into 22. 2 ones, 2 tens, 2 11s, 2 5s. So 7 5s are 35 divided by 11 is equal to 3.2 hertz. And the maximum acceleration A max is equal to mod of minus omega square A, where omega is the angular frequency and A is the amplitude, which is same as x. That is equal to mod minus omega can be written as 2 pi nu whole square into A. I am taking out all these mod and negatives because mod of a negative value is a positive value. So I am writing only magnitude of the given quantity, that is 4 into pi square into 3.2 whole square into 2 into 10 to the power of minus 2. So students, you can simplify it later. We will get a value of 8.0 meter per second square. Now we need to find out the maximum speed of the mass, that is V. V is equal to omega into A, that is equal to omega is 2 pi nu into A, that is equal to 2 into 22 by 7 into 3.2 into 2 into 10 to the power of minus 2, that is equal to, students, you can simplify it later. So we will get a value of 0.4 meter per second. So these are the quantities that we need to find out. A frequency, that is 3.2 hertz, and a maximum acceleration, that is 8 meter per second square, and the maximum speed of the mass, that is 0.4 meter per second.